Video to show off the MicroVerse Masks module. It can be kind of unclear what this is for from the asset description. It's a very technical description as opposed to a use case description. But essentially what you can do with this module is you can generate data for other programs or parts of your program to use. An example of this might be generating stream masks or tint masks for MicroSplat or any other shader, or exporting data that MicroVerse generates for its creation to use for gameplay. And so I'm going to show you basically how this works and set up a simple terrain with it. So first things first, I'm going to create a MicroVerse terrain, and I'm just going to open the browser here and give it some height and texture just so we have something to work with. So let's do just get some basic terrain going here with a stamp, and let's put some texturing on it, and I'm just gonna desert, why not? And then I'm gonna set the range on this to be global. And that doesn't look so hot. Let's just do wasteland for now. Okay, so we have a textured terrain here. Let's say this is our masterpiece and we love it. And we now want to feed information to MicroSplat about where wetness is or where streams are, as an example. So first I need to convert my terrain to MicroSplat, and normally after this was done, I'd spend time adding the height maps and all the niceties that MicroSplat supports. But what we're going to do is just convert it and turn on some of the streams features. And there we go. So let's go to our project here, and we'll go to the MicroSplat editor here, the material editor, and we're going to turn on wetness, and let's also do streams just so we can show both. So the way that you set this up is first thing you do is you create a MicroVerse mask target. And what this is essentially it's a holder to generate a texture for each terrain in a format of your choice that the masks will target and put their data into. Now, it's currently set to be a 1024 texture. You can change that, make it higher or lower. You can select 3 different formats. An R8 texture is essentially a single channel, so you only have one channel of information. You have a color texture, which you would use for like tinting things. And you only want to use a color texture if it's for color information. And finally, you have an RGBA linear. Now, any reasonable shader writer is often going to pack things into an RGBA linear texture. And they're going to do this a lot with masks. And for instance, in MicroSplat, I pack wetness, puddles, and then streams and lava into those 4 channels. So the advantage there is I can sample one texture and get information for all 4 of those systems. So it's a nice speed up. So what we're going to do is we're going to go ahead and create a mask and feed data to the wetness system with it. So let's first create the mask texture, and we're going to create a MicroVerse mask stamp. And that guy is, there he is. So let's just put this on the terrain. You'll notice we don't see anything right now. First, we don't have a mask target set. So we need to drag that mask target object we created into here, and that tells it this is where you're going to dump your data. And you will already see there's a texture added here based on this stamp. Now we can't see anything on the terrain, and we might not have our shader set up yet. We do in this case, but I'm going to go ahead and just hit preview, and you're going to see that currently it's targeting the RGBA channels, and so it's just rendering white into here. We can just target the red channel because that's the channel for wetness that we're going to play with. And then we can use all of our MicroSplat features. We can range limit this to just an area. We can use this curve filter here, and we can, tweak the curve filter until we get something that we like. Maybe we just want, I don't know, wetness there, let's say. Let's say that's just saying how wet our desert is. That's a stupid concept, but because the desert is dry. But let's say that's what we want to do. And we can use any of these filters just like we would on a texture stamp, anything like that. And we can even provide a texture if we would just want to use a texture to project on there. And you can do all your noise filters and your weight of your layer, all of that stuff. And you can use multiple stamps, and you can make them only in a box area or in a range, right? It's kind of hard to see because I'm far away, but you can see here it's just like a little range, and you can size the stamp and all the stuff you would do with any MicroVerse stamp. You can think of it like a texture stamp. And you'll notice that if you click on this texture in the preview here, we can see the data being output. Once we click off the stamp or click off preview, we are back to the regular display. So let's go ahead and feed this into MicroSplat now. So on our actual terrain here, we have a MicroSplat component as soon as the terrain loads. And we have this stream override map. And so if we just drag this in here, we will see that it's put our wetness information on the areas that our mask texture is defining it. And because this is a pack mask, we can go ahead, let's just duplicate this stamp. Now we have two of these mask stamps, and let's set up, we'll just use slope, and let's get rid of the curve one, just to be silly. And we're gonna put this one on the slopes. Now you'll notice this is still targeted to wetness, so we're getting both right now. But what we can do is change that mask target to be the B channel, which is where the stream data is packed. And now the stream effect is on those areas. That needs to be set up, and the animation needs to be turned on my editor or whatever. But you get the idea. It's we can target these individual channels, use all of our stamp capabilities, and then decide where things go. So you could set up your snow mask this way if you wanted to. You could have mask stamps on a building so that it won't get wet under the building by subtracting from your stamp. Maybe the stamp's all white, so everything gets wet, or it's rather the red channel is all filled. And then you use a house has a mask stamp that says where rain, wetness shouldn't appear, and then it doesn't appear underneath the balcony of the house or whatever. So very powerful feature if you want to integrate with external shaders and external data. So I'm just going to go to the example scene and show another setup there. Let's not save this. So the example scene, which is in the package, and if you don't know how to unpack these samples, just read the documentation. Actually, no, they're already unpacked for MicroVerse. So this has two stamps, and if we hit the preview, you'll see that they're taking a texture and projecting it on to this terrain. And so the mask we get out is essentially grayscale with this these two textures, because I have two stamps here. I can move, move one around. And you'll see that there are different blend modes here as well. So I can add this to the terrain instead of subtracting it. And they happen in layer order. So if I invert the layer of these, you can see it's adding to what's underneath of it. So you can composite up stamps. And I think one of the things that this is really useful for is some external packages that generate stamp information, whether using, World Creator or Gaia or whatever, whatever it's called. That information. You can have your color stamp and your height stamp, and so you could just parent the mask stamp to the height stamp so that you get the color and the height for your tint mask all on the terrain, and then it renders out a final tint mask from all of these height stamps and color stamps all blended. And again, all of these, I can have all the capabilities of, MicroSplat or MicroVerse with this, like range fall offs and, change the blending modes of the fall off and add some FBM noise in there to kind of, crank it up or whatever you want to do, right? So that brings the full power of like MicroVerse's texture tool to texturing terrains with external masks and color maps. So the final thing I want to show here, and I got to find the directory here. Here we go. Is what's called a buffer capture target. Now, what you do for this is you create one of these scriptable objects and you assign it to the MicroVerse component. And what the options are in this is to capture various information that MicroVerse generates internally. So in this example, we have everything turned on, but because we don't have trees and things, it's only generating a few things for us. The combined occlusion mask, which has nothing in it because there's no trees, and then the curvature mask, which is the curvature of the terrain. Now, it can generate other information there. You'll see that in that list, you have a tree stamp SDF and tree stamp occlusion map, and then you have the combined occlusion map and combined tree SDF, and then you have the same thing for object stamps. Now, a gameplay example of why this might be useful. Let's say in your game you have objects that the user has to find, and they're all hidden all over the map, okay? And you want to know how close you are to an object to give the user some kind of hot or cold beep, right? That gets louder as you get closer, let's say. Zelda does this with, shrines, things like that. Now, one way you could code this is you could, have a big list of them, check the distance to all of them, and then, see which one is closest, and there you go. Another way to do this is you output this object stamps SDF or the combined one if you want all your objects, but let's just say you do the object stamp one, and you will get a texture in here which has the distance to the nearest stamp. That's what an SDF is. It's just a signed distance to the nearest thing. And by signed, it means it could be negative or positive. In these cases, they're really just positive, right? They don't have negative values because we're dealing with trees and things like that. And so this would output that data, and now all you have to do to tell how far you are from the nearest tree or the nearest apple or nearest object the user has to find is get your position, look it up in the texture, and you get a value back that says how close you are. That value needs to be converted into meters. It is a R8 texture that supports up to, I think it's about 256 pixels away. So that's very cool and could be useful for gameplay things. If you wanted to know, the curvature of your terrain, to know when you're in a chasm versus like on top of a peak. You could use the curvature map for that. So the other feature of this is really just outputting that internal data for whatever you might need it for. That's basically how this all works. And I hope that explains the system and gives you some ideas of how you might be able to use that data in your own game. And certainly if you're using MicroSplat and you're using a bunch of its effects modules, it can be very useful because then you can remove snow from areas, or you can remove wetness from areas, and you can just parent those stamps to your, to your house or whatever, your bridge, and make sure it doesn't get wet under the bridge. And then it all just works as you place objects, which is really cool. So great. Thanks for listening.